Hi, my name is Ricky Dizon, and this is part 2 of mapping my entire target. Now, once we have all the JPEG photos, we run them through a Python code that first applies an HSV color code that distinguishes the red line laser point in each photo. With the individual red line laser points distinguished, the Raspberry Pi can determine how far those individual points are from the middle of the frame. With these frame pixel distances and geometry, the Raspberry Pi can then determine a physical distance. Thus, this gives us X and Y values for each individual red line laser point. Lastly, the IMU angles recorded in the field determine the Z coordinate for each red line laser point. The Python code finally exports a text file that can be then ran in MATLAB to create a 3D point cloud. As you can see here with my scan facing the north, there's a lot of noise. Maybe there's a ambient light that was being captured by the image. So I had to go in and clean this up by physically deleting these points that were way out of the Y range. In order to stitch all 4 scans together, I imported each text file. Then I assigned each text file's coordinates to the respective coordinates of the north scan. As shown, this required some scans to switch X and Y values and negate some values. Lastly, I utilized PC Show 4 times to show each scan individually. In the end, when I put them all in the same 3D plot, we get a rough model of the pillar. In addition, there is a good amount of noise going around towards the pillar and some away from the pillar, so more cleanup can be done. However, the overall scan I'm pretty happy with, as you can make out that that's clearly the same pillar I was scanning out in the field.